tetracycline is a common feed-grade antibiotic used in the beef industry today. It helps to prevent liver abscesses in cattle. However, in the U.S., there has been a substantial increase in condemned liver abscesses. This is most likely due to cattle's gut bacteria becoming antibiotic resistant to feed additives. The picture displays a healthy, normal liver. It is cherry red and uniform. This other liver, however, is unhealthy. It exhibits abscesses pockets, which can not only be detrimental to the animal's health, but also to the beef producer's profitability.
Hey Doc, how's it going?
Good, how are you?
Oh, not too bad. I just got the data back from my last load of slaughtered cattle, and it shows 40% of them had liver abscesses, like this one here pictured that the slaughtering plant sent me. So I was wondering if you had any suggestions. I've been feeding the chlorotetracycline, but it appears that the cattle aren't responding.
Yeah, I'm sorry you're having this problem. It's probably because the bacteria in the microbiome has come antibiotic resistant to the feed that you're feeding them. We have this new product on the market called Microvet, which utilizes CRISPR to knock out the antibiotic resistant gene in the gut.
CRISPR is a gene editing technology used by scientists today to edit a genome. One way to use CRISPR is by performing non-homologous end joining, which is what we will show today. There's basically two components of CRISPR, and it's the guide RNA and the Cas9 protein. So first, a sample needs to be taken from the rumen of a cow that has this antibiotic-resistant gene. Then that bacteria sample is sent to the lab, and it is then DNA sequenced to find that antibiotic-resistant gene. Then that information about the specific location and sequence is then put into the guide RNA, which is attached to the Cas9 protein. Then once the CRISPR components enter the rumen, the guide RNA basically acts like a GPS, and it guides that Cas9 to the sequence. And the guide RNA is complementary to this target bacteria that we're looking for. The guide RNA finds its complementary sequence, which is right here, and then the Cas9 protein will perform the snipping.
This is called non-homologous end joining, which causes the antibiotic-resistant gene to be knocked out. In most cases, the DNA attempts to repair itself and ends up causing a mutation where the antibiotic-resistant gene was placed originally. Therefore, this causes a frame shift and the gene is then silenced.
So this is an example of the microbiome that is in the rumen of a cow, and you can see that it's very healthy and it just has bacteria that's naturally there that is good for the cow. And then in this example, this is the microbiome of a cow that has healthy bacteria, but also there is antibiotic resistant genes present, which are these blue elements.
CRISPR is delivered through the animal's digestive tract via bacteriophage system. The bacteriophage system is a virus that has been injected with the CRISPR components. The bacteriophage system is added into the cattle's feed and reaches the rumen, which is protected by a phage coat which does not get digested. The virus infects the targeted bacteria in the rumen, and CRISPR performs its genome modification. This newly altered bacteria begins to multiply and overpopulates the antibiotic-resistant bacteria, thus decreasing the risk for cattle to develop liver abscesses.
Microvet, huh? The boss said this should work because they're getting pretty resistant to the tylosin. So he gave me this. This is the right amount for this pen. It's about 3 pounds. We're just supposed to put it in the feed bunch and get her a little bit mixed in there.